Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain about the concept of problem solving on normal forms in DBMS. Problem solving on normal forms in DBMS. So generally, what is meant by normalization and how we can achieve the normalization process with the help of different stages called as normal forms. So what is meant by normalization? So normalization is the process of organizing the data in the database. So normalization is what? Normalization is the process of organizing the data in database. So normalization is used to minimize the redundancy from a relation or set of relation. So redundancy, it is used to reduce the redundancy or minimize the redundancy from relation, that is nothing but what? Table, from a table or set of tables, from a table or set of tables. And it is also used to eliminate undesirable characters like insertion, updations, deletion anomalies. So it is also used to eliminate undesirable characters like insertion, update, deletion anomalies. That is nothing but the problems on syntaxes and semantics. And normalization divides the larger table into smaller and links them using the relationship. So the table is divided into smaller tables, that is nothing but decomposition tables, again links them using some sort of relationships. So here the normal form is used to reduce the redundancy from the database table. So there are different types of stages or the different types of normal forms are there to achieve the normalization process. So normalization works through a series of stages called normal forms. Normal forms applies to individual relations. So normal forms are applied to individual tables. Individual relations are nothing but individual tables. The relation is said to be a particular normal form if it satisfies constraints. So if any normal form is said to be in particular normal form if it satisfies the particular constraints. To achieve that normalization process. So here following are the various types of normal forms. So first normal form, second normal form, third normal form, fourth normal form and fifth normal form. So here you can see all the decomposition of relations and the conditions or constraints that are satisfied to achieve that normal form or stages. So first normal form, it eliminate repeating groups. So the constraint is what? The constraints on first normal form is what? Eliminate repeating groups. And the second normal form constraint. So the second normal form constraint is what? Eliminate partial functional dependency. And constraint on third normal form is what? Eliminate transitive dependency. And the constraint on fourth normal form is what? Eliminate multi-values dependency. And constraint on fifth normal form is what? Eliminate join dependency. So these are all the constraints that are applied on satisfied to normal forms. So here each and every normal form and its description. So the first normal form description is what? A relation is in first normal form if it contains an atomic values. And the second normal form is that a relation will be in second normal form if it is in first normal form and all non-key attributes are fully functional dependent on the primary key. So a relation will be in second normal form if it is in first normal form and all non-key attributes are fully functional dependent on the primary key. So non-key attributes are fully functionally dependent on primary key. And third normal form is what? A relation will be in third normal form if it is in second normal form and no transition dependency exists. There is nothing but transitive dependency. No transitive dependency exists. No transitive dependency exists. And for the third normal form, the stronger definition of third normal form is also known as what? Boyce-Codd's normal form. That is also called as BCNF. So Boyce-Codd's normal form. And fourth normal form, a relation will be in fourth normal form if it is in Boyce-Codd's normal form and has no multi-valued dependency. So multi-valued dependency, it should not contain multi-valued dependency. And fifth normal form, a relation is in fifth normal form if it is in fourth normal form and does not contain any joint dependency. So the joining should be lossless. So here we see each and every normal form, how it having to decompose the tables and how it reaches. So here the first normal form, a relation will be in first normal form if it contains atomic values. So it eliminating grouping values. So it should contains only one value or atomic values. So it states that an attribute of a table cannot hold multiple values. So it states that an attribute of a table cannot hold multiple values. It must hold only single valued attribute. First normal form disallows the multi-valued attribute like composite attributes and either combination and their combination of attributes. So an example here, the relation employee is not in first normal form. The following table is not in first normal form because of multi-valued attributes of employee phone. So here in this table, employee table, employee ID will be there, employee name column will be there, phone and state. But all these four attributes, employee phone having multi-valued attributes. So it is having multi-values. So to eliminate that one, to remove that one, to make it as atomic values, we need to decompose the table. We need to perform decomposition of an employee table into first normal form. So how it decomposed? So same, the employee ID, employee name, employee phone, employee state. So we need to assign each and every value to each and every employee ID. So we need to assign each and every value to each and every employee. So employee ID 14 having John employee name with the following phone number. Similarly, employee ID 14 having the employee name, having the phone number is separated value. So like the way you can decompose the values. You can decompose the values in the table. And the second normal form. In the second normal form, the relation must be in first normal form. So first it should be in first normal form. And in the second normal form, all non-key attributes are fully functional dependent on the primary key. So all the non-key attributes are fully functional dependent on the primary key. So let us assume that a school can store the data of teachers and subjects they teach. In a school, a teacher can teach more than one subject. So here the teacher table contains what? Teacher ID, teacher subject and teacher age. So here the teacher ID 25 will teach both chemistry as well as biology. And similarly here other teachers will be having their subjects. So in the given table, non-prime attribute teacher age is dependent on teacher ID. So it is a non-prime attribute teacher age is dependent on teacher ID, which is a proper subset of candidate key. So that is nothing but it violates it violating the second normal form. It violating the second normal form. So actually, the second normal form says that what? Eliminating partial functional dependencies. Eliminating partial functional dependency. That means it should depending fully. It should have fully functional dependency. It should have fully functional dependency. So here, eliminate partial functional dependency. Eliminate partial functional dependency. So to convert the given table into second normal form, we decompose it into two tables like this. So one is teacher underscore detail. The teacher age is completely fully functional dependent on the teacher ID. And similarly, the subject is also fully functionally dependent on the teacher ID. So now these two columns, the non-prime attributes. So these two are non-prime attributes. Non-prime attributes are fully functionally dependent on prime attribute, primary attribute, functionally dependent on primary attribute. So this is the way you can decompose the table into become a normal form. And third normal form, a relation will be in third normal form if it is in second normal form and not contain any transitive partial dependency. And so it should not contain any transitive partial dependency. So it should contain what? Fully transitive dependency. So here third normal form is used to reduce the data duplication. It is also used to achieve the data integrity purpose also. It is also used to achieve the data integrity. If there is no transitive dependency for non-prime attributes, then the relation must be in third normal form. So if there is no transitive dependency for non-prime attributes means the relation must be in third normal form. So a relation is in third normal form if it holds at least one of the following conditions for every non-trivial function dependency x tends to y. For every non-trivial functional dependency x tends to y. So here x is nothing but it is a super key. So suppose id is a super key and y is a prime attribute. That is, each element of y is part of some candidate key. So here, see the example. Employee underscore detail table will be there. So that contains what? Employee ID, employee name, employee zip, employee state, employee city. So all these details. So here employee zip and employee name will be depending on employee ID. But employee city, employee state will be also having depending on employee zip. So here there is not having fully functional dependency. To make it fully functional dependency, we need to decompose the tables like this. So one is what? Employee ID, employee name, employee zip. So now employee zip is fully transitive dependence on employee ID. So here the super key in the table is what? Employee ID, comma employee name, comma zip. Like that. So candidate key is what? Employee ID is the candidate key. So non-prime attributes in the given table, all attributes except employee ID are non-prime. Here employee state and employee city are dependent on employee zip and employee zip dependent on employee ID. So the non-prime attributes employee state, transitively dependent on super key, that is employee ID, and it violates the rule of third normal form. So that's why we need to move the employee city and employee state to the new employee zip table with the employee zip as a primary key. We need to move that employee state and employee city to the employee zip table. So how can we move it? So here employee table which contains employee ID, employee name and employee zip, and here the employee zip table contains employee state, employee city. So these two are fully transitive dependent on employee zip, fully transitive dependent on employee table. So this is the way the fully transitive dependency will work in third normal form. And the stronger normal form of third normal form is what? Boycott normal form. So boycott's normal form. So BCNF, we can call it as what? BCNF, and it is the advanced version of third normal form. It is stricter than third normal form. So a table is in BCNF if every functional dependency extends to y. Every functional dependency extends to y. X is the super key of the table. X is the super key of the table. For BCNF, the table should be in third normal form, and for every functional dependency, the left hand side is a super key. Left hand side is a super key. So the employee ID or employee age, employee name, anyone which is having left hand side must be a super key. So let us assume there is a company where employees work in more than one department. Employees work in more than one department. So employee table contains what? Employee ID, employee country, employee department, and department underscore type, employee underscore department underscore number. So here the details will be having employee ID, country, employee department, department type, employee department number. So in the above table, the functional dependents are as follows: employee ID, employee country. So employee country is fully functional dependent on employee ID. And similarly, department type and employee department number both are fully functional dependent on employee department table. Employee department table. So here the candidate keys are what? Employee underscore ID and employee underscore department. So the table is not in BCNF because neither employee department nor employee ID are alone are keys. So it is separated and it is separated. So to convert the given table into BCNF, we decompose it into three tables. So we need to decompose it into three tables. So what are those three tables? Employee underscore country table. That means completely employee country will be depending on employee ID. And similarly, department type and department number will be having depending on employee department. And similarly, employee department is also depending on employee ID. Employee department is also depending on employee ID. So here the employee now it is fully functional dependent and fully transitive dependent. Fully functional as well as fully transitive dependency. So employee department number, employee department type, employee department, both are having fully functionally as well as fully transitive dependence. So here the functional dependencies of what? This table is what? Employee ID, employee country, and here employee department and department type, employee department number. So candidate keys for the first table. So here the first table candidate key is what? Employee ID, and for the second table is what? Employee department, and for the third table is what? Employee ID, employee department. Employee ID, employee department. These are the candidate keys. Now this is in BCNF because left side part of both the functional dependency is a key. So this is because of BCNF. This is because of having the left hand side. Because of having the left hand side, it is a BCNF. It is in BCNF form. And fourth normal form. A relation will be in fourth normal form if it is in Boycott normal form and has no multi-valued dependency. For a dependency, A tends to B if for a single value of A, multiple values of B exist, then the relation will be a multi-valued dependency. So it contains what? The student ID, student course and a hobby. So it should not have any multi-value dependency. So the attribute does not have multi-values. The given student table is in third normal form, but the course and the hobby are two independent entities. Hence, there is no relationship between course and hobby. So to make that happen to fourth normal form, in the student relation, a student with student underscore ID 21 contains 2 courses, and computer and math and 2 hobbies like dancing and singing. So there is multi-value dependency on STU ID. So there is 2 multi-value dependency on student ID, and which leads to unnecessary repetition of the data. So to make the above table into fourth normal form, we can decompose it into two tables. So what are those two tables? Student underscore course is one table. Student underscore hobby is one table. So one is student course table and student hobby table. So now it is having a dependence. It is fully functional dependent as well as fully transitive dependent also. And similarly, hobby is also student ID and student hobby is also having the same. So like the way the fourth normal form exists. And fifth normal form, a relation is in fifth normal form. If it is in fourth normal form and not contains any joint dependency, and joining should be lossless, So fifth normal form is satisfied when all the tables are broken into as many tables as possible in order to avoid redundancy. And for this reason, fifth normal form is also known as project join normal form. So because of that, joining should be lossless. It is mainly focusing on joining. So project join normal form. So take an example. So the table is what? The lecturer subject table. So table is what? Lecturer subject table. Contains what? Subject, what the lecturer teach, and the name of lecturers and the semesters for what semester they teach. So in the above table, John takes both computer and math class. So here John takes what? Both computer as well as math class for semester 1. But he doesn't take math class for semester 2. In this case, combination of all these fields required to identify valid data. So exact data we need to identify. So whether he is teaching for the semester 1 or semester 2, whether he teaches the subject to the semester 1 or semester 2. So we need to validate the data. So suppose we add a new semester as a semester 3, but do not know about the subject and who will be taking that subject. So we leave lecturer and subject as null. But all three columns together act as a primary key. So we cannot leave other two columns blank. So at that moment, what should we do? So to make that above table into fifth normal form, we can decompose it into three types of relations, like R1, R2, R3. So the first one is what? Semester and subject. So from this subject to lecturer semester, we can divide it into semester and subject as one table, the next subject and lecturer as one table, and semester and lecturer as another table. So now here the semester 1 contain computer, semester 1 contain math, semester 1 contain chemistry. So now by decomposing the process, we can validate who will teach the computer subject to the semester 1, who will teach the math subject to the semester 1, and who will teach the chemistry subject to the semester 1. So by decomposing all this table, we can conclude that whether the lecturer is suitable to give the lecture to subject to the semester. So here the subject and lecturer. So Anshika is giving a subject computer, and John also taking the computer, and John also taking math, and Akash also taking maths, and Praveen also taking chemistry. So now they have their choices, but how they are going for the semesters? See here, so Anshika is going for what? Semester 1 for what subject? Computer subject. So semester 1 for computer subject. And similarly, John for what? John for John for computers. For what? For semester. So semester 1. So semester 1. And similarly, Akash is for semester 2. Praveen is semester 2. So like the way we can conclude that each and every lecturer will take a subject to the particular semesters. So now the data is validated. So this is about the normal forms that to achieve the normalization process. So once again we revise the topic which we discussed in this session. So here the first one is what is meant by normalization. So what is meant by normalization? So see here. So for every achieving of normalization we have to follow some constraints. So here what is meant by normalization? So normalization is a process of organizing the data in database. So how you are organize the data in database is important. So we can have two types of choices. One is what we can decomposition of the tables. One is what the choice is decomposition of the table, and the second one is the choice is what constraints, applying constraints on the normal forms. So two choices is what two choices for achieving normalization. One is what decomposition of tables. One is what decomposition of tables. And the second one is what applying constraints on normal form. So by doing these two, we can say that each and every stage is satisfied. So normal forms are applied to individual relations. Individual relations are nothing but individual tables also. So the relation is said to be in particular normal form. Yeah, when we can say that if it is satisfies constraints. So the types of conditions or constraints normal form. So on first normal form, the constraint is what? Eliminate repeating groups. On second normal form, the constraint is what? Eliminate partial functional dependency. On third normal form, eliminate transitive dependency. For fourth normal form, eliminate multi-values dependency. For the fifth normal form is what? Eliminate join dependency. So to say that the data is in first normal form, you have to satisfy these constraints. So for this all the satisfying constraints, we can say that the data is in first normal form. So here the normal forms and its description. So the first normal form is what? A relation is in first normal form if it contains atomic values. The second normal form, if it is in second normal form, it is having first normal form, and also all non-key attributes are fully functional dependent on primary key. And for the third normal form, it is in second normal form, and no transitive dependency exists. And the BCNF, it is a stronger definition of BCNF. It is a stronger definition of third normal form, and it is also called as Boy-Scott's normal form. And for the fourth normal form, a relation will be in fourth normal form if it is in Boy-Scott normal form and doesn't have multi-valued dependency, and it has no multi-valued dependency. And for the fifth normal form, a relation is in fifth normal form if it is in fourth normal form and does not contain join dependency, and here the joining should be lossless. So the first normal form. So we need to perform two steps. What is then? One is applying constraints under decomposition of the table. Second one is decomposition of the table. So here the employee table is having multi-values. So we need to make it as a first normal form, means we need to split the data into twos. So now the data is splitted. Now the data is decomposed. So decomposed data will be saved. And similarly, second normal form. So second normal form is having the functional dependent on the primary key, and all other non-primary attributes are fully functional dependency. So here the teacher detail, teacher subject, Here teacher age, teacher subject are fully functional dependent on teacher IDs. Fully functional dependent on teacher IDs. And third normal form. So in third normal form, relation will be third normal form. It is fully transitive dependency. Fully transitive dependency. Fully transitive dependency. And no other attributes will be having the non-primes. No other attributes are having non-prime attributes. So here the candidate keys are dependent on determinants, and super keys are dependent. And voice card normal form. So it is having a fully functional dependency on the left side, and other attributes, all other non-prime attributes are depending on the prime attributes. So here candidate keys are presented, super keys also presented. The left hand side of the keys are presented as a candidate keys, and they will be the functional dependencies also. And fourth normal form does not contain multi-valued dependency. Multi-valued dependency. So if any multi-values, then it will be decomposed. It will be decomposed as a tables. And fifth normal form, it does not having a join dependency. So it does not contain any joining dependency, and joining should be lossless. When you are joining those three tables also will get the same as which we decompose the tables. So this is all about normal forms to achieve the normalization process in the database management system. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.